fetch from that location. And that's the concept of a pointer. Okay, so how do you create a pointer? Let's what you do is, let's say I have a variable called age, and my variable as, let's say, 55. So it means if age stores the value called 55. Then for me to create a pointer, say int, then you put your asterisk with the pointer name. It doesn't matter. It can be age underscore PTR. It's always good to give a descriptive name. So this is more like age pointer, pointer to age. You understand? Pointer to age. So that you won't. So with this, I've created my pointer. Okay, but the pointer is not pointing at anything. Okay, it's not pointing at anything. Yeah, I can come here and say age underscore PTR is pointing to the address of age. It's pointing to the address of age. Okay, so just imagine I have another variable called age 2 and it has 60. All right. So at first, this pointer, age pointer, is pointing where? Pointing to age variable. It's pointing to age variable. With this pointer, I can actually fetch where it's pointing to. If I'm pointing at you, I can access you, I can read to you, or I can write to you. I can fetch what you have. Okay, so just imagine this is age. I have age here, and age has the value of 55, and age has a memory address. Let's imagine this is the memory address, 2F, whatsoever. Let's just keep it simple, 2F. Okay, I have another variable called pointer, age pointer, age underscore PTR. Okay, and the age underscore PTR, this the pointer. I've created the pointer with this line. Now I am referencing, this pointer is referencing age. It means this pointer is pointing to age. Okay, it's pointing to age. The term pointing is, we call it referencing. That pointer is referencing to age. So pointer does not store a value. What a pointer stores is the address. Okay, so the pointer is now storing the address of age. And so that's what you will find in a pointer. That's what you will find in a pointer. All right. So with the pointer, since I'm pointing to age, I can actually write a new value to age. I can change the value in age, or I can access the value in age. All right. So how do I do that? With here, I can print out, let's say, using pointer, or I can come here and say value of age using pointer. Value of age, and just give it a tab spacing, and what will be the value. Okay, so since age is integer, then so with this I can dereference. Dereferencing means you are trying to say, oh, go to the address or go to where I'm pointing to and fetch me the value. So with this dereferencing, I am saying go to the address or I'm pointing at and fetch the value. So with this now, I am accessing age. I'm accessing age via the pointer. Okay, so let's run and see what we have. You can see the value of age using the pointer is 55. because the pointer is pointing at age, I can actually fetch what I have there. Okay, all right. So I can come on a new line and say, remember, where I am pointing at, okay, where this pointer is pointing at, the value should be changed to just a minute, guys. Just a minute, guys. So where I'm pointing at, I want you to change the value from 55 to 100. All right. So I can also come, I want to verify directly. Okay. Let me just, um, the new, let's say the new value of age. Okay. The new value of age is, let's just keep it that way. Now you will see that if I just print out the value of age, the new value of age will be changed, would have changed. Okay, you can see the age, the value of age has changed. Why? Because I use the pointer. So using the pointer, what I'm saying is now this 100 should go to where the pointer is pointing at. Okay, so this is dereferencing. This dereferencing operator, okay, the dereferencing operator is trying to say go to where I'm pointing at, this pointer is pointing at, and put 100 there. So with that, what we now did is we are able to cancel this and change the value to 100. Okay, so the pointer is very powerful because if you know of any address and you can point at that address, then you can fetch the value there, you can change the value there. Anything I point at, I can change the value. That is to say, I can write to that location or I can fetch the value in that location. All right. So that's the concept of a pointer. Okay. Another thing I will want to make us understand is this. The pointer, you can use pointer. Okay, let me continue with what I'm trying to explain. So I am pointing at age now, okay? The pointer can come again and say, oh, I don't like age anymore. I don't like age. Let me point to another variable and call it age2. Then with age2 now, I can use the pointer. I can fetch. So the value of age2 using the pointer. So the pointer is pointing at age2, so I can dereference where it's pointing at. All right. So, oh, sorry, there's something is still running. Okay. Let me abort. Something is wrong somewhere. Blah, 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 blah. Okay. Sorry. Let me just save. Okay. Let me close it. Let me close my workspace and open it again. Close project. Right. Let me open it once more. Once again. I hope you guys are still with me.
Yes, sir.
I wonder why I'm having. Okay. Let me close it and close the workspace. Close it. Let me just quit. stop. Yes, I want to stop compilation. Yeah, it's compiling. That's why I cannot run it. So a minute, let it stop compiling and exit. Stop. Let me look at the R chart. Right. Close to free the memory. So pointer is very powerful, and that's why I'm taking my time to explain pointers to us, because I'm going to be talking about dynamic memory allocation, and the dynamic memory allocation works when you're using a pointer. Okay, very powerful. It's when you create a memory dynamically, it returns the address, and that address will be held via the pointer. Wonder why it's not responding fast. Okay, so that's why I had to go through, explaining what a pointer is. Okay, let me close it. Close. So the concept of a pointer is very, very important. Very, 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 very important. Okay, because if you want to study advanced topics like data structure and algorithm, you want to create trees, linked lists, um, stack queue, stuff like that, dynamically. Because sometimes you can create all this stack, linked list and stuff using an array. It's not compulsory to use dynamic memory allocation. Okay, but when you do that, you know, uh, you need to have a firm understanding of pointers. Okay. Okay, so you can see that now the pointer here is now pointing at a new variable. Okay, it's just like saying, oh, I'm divorcing age. No more pointing at age. I want to point to a new person, age 2. Okay, so that's what the pointer is doing now. The pointer can change wherever it's referencing. Okay, wherever I'm referencing, I can change it and stuff like that. So let's see. The pointer is, oh, please guys, whenever you come online, come to class, meet yourself. Very important. Okay, so the pointer was pointing at age initially, but now is pointing at age 2. So then you will see that we can actually fetch. So the new value, the value of age 2 is now 60. You can see I did not properly format it. So come here, format. All right. So you can see now that now the value of age using pointers is 55 now. The value of age 2 using pointer is 60. So I've been able to access those locations. Okay, that has been sorted. Again, if you look at the concept of array, let's say you have a variable called student. Okay, and you create, let's say, 10 students. All right, 10 students. Then you can use the concept of pointers to fill in the location of those students. Okay, and how do you do that? Automatically, when you have when you create an array, okay, behind the scene, a pointer is created, okay, which is pointing to the address of the first location. That is to say, student index 0. So let me create a pointer and say pointer, pointer, or I can call it student pointer. I don't want to make it more descriptive, which is very good. I can say, I can do this. I can just say equals student. Should be able to equals to. Okay. So let me just run. It should not give me any error. Okay, that's fine. Equals students. Then I can say in I'm pointing at the first index. Then I can do this where I'm pointing at. Where I'm pointing at. Sorry. Should have 100. Okay. If you come here, the value of students, value student in position, or let me say in index 0. Yes, sir. Is yes, sir. You're welcome, sir. Is then the index 0 with the index of 0. Then you can do this. Yeah, good afternoon. Welcome. Oh, thanks, though. Wow. This is my programming. Having a parfait. We use my programming. Okay. So just imagine, let me just say students index 0. What I'm trying to show you is you would notice that the pointer has affected the index, has helped you populate. Okay, has helped you populate the students with index 0. What this means is more like PTR equals index 0.
It's upside down. You want to point it out.
Okay.
It's upside down. You just cut on the floor.
Oh, okay. All right. So this is more like this. You're pointing. Maybe I should remove it. So this, you understand? So the pointer is pointing at the first address. Can anyone tell me why in an array you have a pointer pointing at the first address? And what's the significance? What's the significance?
Yes,
I want comments. If you don't want to comment, you can actually write on the chat box.
Array looks like a block of memory. So
your voice is scrambling. The voice is scrambling. I don't know. You can comment if you feel like the voice are not.
Degree has the highest degree can get a doctor.
Okay. Any other person? Why do you think the pointer, by default, you have an index, your pointer is pointing at index of 0.
Okay.
Just like this, when I do this. I need feedback so that.
Okay.
I'm trying to understand how when to use them, when not, when to use the comparison.
Hello, okay, guys.
Let's let you.
No. Yeah.
For most part, question.
Yeah, thank you, Baba Heritage. Thank you, Heritage. Now, the concept is just this. He has explained it. If array is a contiguous block, okay, is a contiguous block, one after contiguous means one after the other, sitting line, just like our houses on a lane, they are beside each other. So if you go to the first house has the index of 0, according to memory, in C, yeah. If the first house has the index of 0, it's easier for you to move to the next house. Okay? For you to go to the next house. All you just have to do is to move, just a block. The next house is just 2 blocks, just another block, just another block. You understand? So from the first index, you can displace yourself and move to other blocks, and you can actually put values in those blocks. Okay, so once you have that clear understanding, you can actually access this location. Let me see comment. Okay, so you can see by default I've been able to let me see. Okay, can you see? As that of 0. Can you see? So can you see? Then there's something called pointers arithmetic. I can do this and I love prefix incremental. I do this and I say 120. Okay, I increment the pointer. Let me just do this so that you guys will be able to see. Okay, then I can print. I just want to show you. Okay, so the student index 1 as what? You can see here I'm using pointers to access it. Here I'm using students. I want to see if what I did with pointers, okay, affected the student. That's the whole essence. Let me come to the line. Can you see the value of student in the index? Oh, 0. Well, never mind. Let's say index 1. Okay. All right. You can see. So the pointer now, I'm saying go to the next one, increment to the next address, and with that, I can actually use a for loop also. Can use a for loop to be able to traverse those locations and put a value there. So that's the concept I want you to understand. I'm just trying to explain and reinforce those knowledge for you. Okay. Today we want to continue from the concept of a pointer. Before I continue, I also want to explain something which I also believed I did in the last class or before the first semester. If I create a variable called student, okay, let me just say I assign value of 80. You can know the size reserved on the computer memory. You can know the size reserved on the computer memory for that variable by using what we call size of, okay, the number of bytes. So you can actually come here and print the size, let's see,
Call by reference. Zero reference.
size
Over of the calculator, something like
this, size
Yeah, call by reference. Zero reference.
size of
One
what?
thing that call by reference.
Size
The
of
first thing is that call by
don't
reference. I need to see the function in English.
don't
It doesn't carry anything. It just looks like call by one. You have to get the function to know whether it's call by value or call by reference.
okay. So with the size of, you are able to see that for an integer, student is of an integer, the number of bytes reserved on the computer memory is 4 bytes. Okay, it's 4 bytes. And for you to even have a clearer understanding, you can create an array and look at the address of the array and the next address. So I can start from index 0, then look at the address of index 1. I will see that they've changed by 4 bytes. Okay, by 4 bytes. Okay, so today I just want to explain memory management. Okay, and memory management is a way or a process of you handling your memory. Okay, how much memory your program uses through different operations. How much memory a program uses through different operations. Okay, so that's memory management. In C, C is very rudimentary. Rudimentary in the sense that you have unlimited privileges because you are using pointers. Using the pointer, I can map to any memory location and fetch what is in that location. Okay, you can fetch data from any location. You can point to any memory location and write data to it. However, it is very dangerous because that program can be, that location can be used by another program and it crashes the program. Okay, so because you have unlimited privileges using pointers, one must be able to manage and be conscious of that, manage it very well. Okay, in higher programs like C++, the compiler handles the memory band for you. Okay, so if I have, let's say, if I have an array, let me try to show you something. Let me try to show you something. Let's say I have created, you know, I created, you know, something like this. Okay, and look at this. I can, and I do this. Just imagine I do this.
Most times,
It will still run. It should have complained to me that, oh, what you are trying to do, you are going out of your range. You are going out of your range. Okay? I created an array with just two locations. Okay, index 0 and index 1. Okay, because the size is just 2. Now I'm trying to access the third location, which does not exist. However, if I come here and run, it still works. It works, but it can, that location might be used by another variable, and I corrupt the memory. I can corrupt the data. Okay, I can corrupt the data, and that is extremely bad. Okay, that's extremely bad. All right, so we need to be very cautious because we have no limitation. We have no limitation in C. In C, we have to be very conscious. All right. So, like I showed you there earlier on, size of operator. That size of operator will show you the number of bytes reserved. Okay. Using the size of operator, you can see the number of bytes being reserved for you. So, so just imagine the size of. Okay, Just imagine I'm doing size of int.
You come across them, you see you can use them.
Those libraries.
Other libraries.
Int also have 4. Now, if int has 4 bytes, any variable you create of the type int will also have 4 bytes. Imagine that you are having, if you've ever gone to bakery, you understand, in bakery, you always have a container, your baking pan, okay, in bakery, and you put your dough or your flour, you put it in your baking pan. You will always see that the bread also would be of the size of the baking pan. Do you understand? It will limit itself to the size of the baking pan. So if int is 4 bytes, if the size of int is 4 bytes, any variable you create from int will also be 4 bytes. Okay? And I love C or C++ with this, in the sense that you can still modify the size. Just imagine I don't want 4 bytes because it's too much. I need a shorter byte. Then I can come and say short int. I can modify it and say short int. Okay? Short int. Or I can still go further to modify it and say this variable called age should be unsigned. Should be unsigned. I can say it should be unsigned. Okay? Unsigned meaning what? It should only be positive. It should only be positive. Okay? So those are stuff you need to know. Okay? All right. So it's very important. It's very important. If you create a program that occupies too much memory or unnecessary memory, it can result into a slow program. Do you understand? It can result to slow program or poor performance. And that's why I learned you guys are doing what we call fundamentals or introduction to data structure. All right. In data structure and algorithm, especially in algorithm, actually, it is not about you writing program. It's also about you writing efficient program. Efficient program. So we need to test your program. We need to test your program in terms of space or a time complexity. How many bytes are you using to perform the same operation? So if I have someone writing a program and all they use is 500 MB, and you also write a program and it uses 50 MB, 50 MB of storage, I would actually select your 5 or 50 MB over 500 MB. Okay, I will select 50 MB over the 500 because you are saving. You're saving space. Okay, you're saving space. It's very, very important. You know all this. Okay. So memory management is. Just give me a minute, guys. Give me a minute, guys. Just a minute. So that's the concept, guys. That's the concept. That's the concept, guys. So you need to manage your memory yourself in C. The compiler will not do that for you. Okay. So
Makes sense, right?
Because it is possible for you to destroy data in other locations. Because you can point to any memory location, you can actually point to another location and destroy the data. Okay. So in memory management, for you to create or reserve memory, we call it allocation. So I can ask you, what is memory allocation? It's a process of you reserving what? Memory space. And that's what we call allocation. Remember, what we're doing now is what we call static memory allocation. Okay. In static memory, the memory is reserved for variables before the program runs. Okay, before the program runs, the memory is created statically, for you. And again, we also call it compile time memory allocation. Okay. And the issue there is sometimes we waste space. We waste space. Just imagine I create an array. For an array, you will have to predefine it, the size. What if I don't use all my size? What if I create a program using an array and say, okay, the population of Nigeria will be 50, or will be 5 million, and tomorrow it becomes 10 million or 20 million? What happens? It means I under budget. What if I create 20 million and the population is just 5 million? So it means I'm underutilizing those the space. Okay. Guys, sorry, I'm a bit distracted. Just a bit. Apologies, just give me about 5 minutes. Let's have 5 minutes break, guys. 5 minutes break.
And there's the
Okay. Sorry about the break in transmission. Ooh. Sorry guys, are you still with me?
Yes, sir.
Yes, sir.
Thank you so much. Thank you so much. So for static memory, you can reserve memory during compile time and also during runtime.
That is from this.
So on runtime, during runtime, you have no opportunity to be able to create, to give a variable name. Okay, so during runtime, if you want to, create space, all what you would do is the compiler create space for you, or the program create space for you, and give you the address of that location it has created for you. So it means you will need a pointer, you will need an understanding of pointer to be able to manage that memory address, which has been created for you during runtime. Okay, but during compile time, yes, you can still give a name in your code, variable name, and while compiling, the compiler will help you reserve space. Okay, so in your static memory, you can actually waste space or waste memory location. You might not use all the necessary space you've declared. Just like this, if you're having an event, you can say, oh, I'm budgeting 500 guests. And at the end of the day, 200 shows up. You can also say, I'm budgeting 500 guests. And the way we do, the Yoruba call it Mogbomo branch. You are coming, you're bringing two other friends. The two other friends are bringing two other friends. And at the end of the day, there's overestimation. Okay? So what do we do in situations like that? So in static memory, sometimes we waste spaces, okay? And all this has complexity, has cost. There's a cost in terms of time. Time talks about the speed at which a program runs. There's also a cost in terms of space. So we always say time complexity and space complexity. How many memory location? What's the size of the memory this program is using, the overall space? Or what's the time it takes for this program to run? All right. So it's very important that we have a firm understanding of dynamic memory allocation, and we'll be able to use it. So in static memory, we said memory is reserved for variables before the program runs. Before the program starts running, you create space memory. While in dynamic memory, you allocate the memory after the program runs. The compiler does that for you. Okay? Or that's what we call runtime memory allocation. Memory allocation during runtime. So you need to have full control of how much memory you use at any particular time. Okay, so if you have to do anything as regards memory allocation, you would have to include standard library, the header called std_lib. Okay, you have to include this so that you'll be able to allocate memory. All right. So there are functions in C that can help you with memory allocation. We have what we call malloc, the malloc function, and also the calloc function. Okay, the malloc and what? And the calloc. There's also another function called realloc. It helps you reallocate memory. So maybe the initial memory you created, dynamic memory you created, was just for 4 variables, or the size of, let's say, 16 bytes, and you want something like 200 bytes. Okay, you can reallocate. So, and that function is realloc, okay, which can do that. So for us to create memory, I can come here and just say I create a pointer, okay, and I can come here and do this. Like this.
So go that one.
Unlock
I have a missing part.
and the size. The size of like size of
I just make it into people.
so so basically this first one is just help me to help me cast, so it's not compulsory.
How we are doing
It's just to, because when you create malloc, it gives you a pointer to a memory. It returns a memory address, okay, and I want it to match this pointer. That's the reason I'm casting it. Okay, so for malloc, the major thing you can see void. It returns a void pointer.
I can tap this one.
It just gives you a memory block.
Line number.
It does not know whatever you want to put there. Okay, it is you that will now say, oh, I'm putting an integer. So followed by the size. You can see it's followed by the size. There's nothing like int. This memory will be int or float or whatsoever. All you do for malloc is to pass the size in bytes, the size in bytes. And that is why I'm using size of, because size of operator gives me what? The number of bytes a variable or a data type uses. Okay, so this size that is required by malloc, I got it using size of int. Okay, so that is what I'm doing. That is what I'm actually doing. So let's see if it works. Okay, you can see dynamic memory allocation. But what I did is somehow wrong, in the sense that when you dynamically allocate a memory, when you're done, you should free it. Okay, you should free the memory. It's always important. When you're done, you free. So when you're working with dynamic memory allocation, two things you must do, very important. Number one, you must test or check for errors. If there are errors, let's just imagine the scenario. My memory is full. There's no space, and I asked it to create dynamic memory for me. And if it does not have a space, or if there's an error in creating, how do I know that it has done that for me? Okay, so it's very good for you to check for if pointer, something like if pointer is equals to null, is equals to null, okay, is equals to null. You have to check it. Then you can then say unable to create dynamic memory allocation. Okay, you can just say unable to reserve space, something like that. Okay, unable to reserve space. If I'm unable to reserve space, then I can exit. I can exit. Exit failure. I tell the operating system, sorry, I'm exiting because I failed. Otherwise, it was okay. It's run. No problem. Sorry, guys. Let me. Okay. Okay, so the exit function is for you to just, exit out of the program. Stuff like that. All right. So you have to check, and this is what I've checked. And when you're done, always free your memory so that other programs can use that memory. All right. So that's Very, 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 very important. And this is how to use the malloc function. You can also use the calloc. Okay, there's also what we call calloc. You see the calloc function. Calloc function. See the calloc function more like an array. You will specify. Look at what he's asking. You specify the size. The size. You know, you can see it's two arguments. Size, two size. The first is you have to specify the more like the amount. Okay, the amount of memory, just like an array, the amount of memory you want to reserve. So let's say 10 followed by the size. Okay, the amount followed by what? Followed by the size. What if in the malloc, I want to create more like an array of dynamic memory? I need just 10. So what I will do is I will say, remember, it is byte, the byte that malloc deals with. Okay, so then I will just multiply. So size of int will give me 4 bytes. Then I'm now asking it, I need 10 of it. Okay, I need 10 of it. So that's how you can create more like 10 memory location. 10 memory location. Okay, so 10 memory location. So you can also use the concept of pointer and say, remember, it will be pointing to the first address. So you can actually say this equals 200. Okay, this is still the same as doing this. Okay, index 0. And say index 0 is 200. Okay, so it's just like that. Then you can then say, so when you create memory like this array, then you can still use the concept of indexing. Then you can say, oh, the pointer index 1, you understand, equals to 50. The pointer index 2,
this part is still available.
It will be 300. Stuff like this. Stuff like that. Okay. So let me just do 3.
So most times you find yourself.
Okay. Let me try to access. Let me try to print and see the pointer. Where the pointer is pointing to is.
That part. Yeah? Let's go for it. Come on.
I mean the 0 value. Yeah. Let me just do this. This. Of my what?
That's what we should at the bottom.
You can see. So that is what index 0 is that. Okay. I can actually say let me see. I'm not too sure. Let me confirm.
I don't need to know that. Just know that.
Index 1. Let's confirm. Index 1, 50, you can see. So index 2. Index 2, 300. Okay, so the beautiful thing is it uses the concept of an array, you know, to do that. And when I'm done, I can actually free what? I can actually free the memory. I can actually So the same concept, you can also use the same concept with calloc. Remember, malloc, the argument you pass to malloc is the size you want in bytes. Okay, so and that's the reason I'm using the size of int. Then I'm telling it I need 3 of it. Okay, that's the other way you can also use to create is when using calloc. Calloc will tell you the number you need, which is index 3, and followed by the size. Okay, calloc. So I can create 4 of it, and still using the same concept. Let's see. See, it's index 0 is 400. Index 0, okay, 300. I can do the same thing. Yeah, it's them. Index 0. Let me just say index 0. Index 1. Index 2. So that's it. You see, index 0, 200, 250, and what? And 300. So that's a wonderful. That's a wonderful concept. Okay. Wonderful concept.
Why these are becoming Python and the rest because of the
okay, so that's what I
is essential for low level control.
want to explain to you today. Okay. And again, I've also explained, have I explained the concept of multi-file to you, guys?
Okay. So don't worry, I'm sure you.
Have I explained the concept of multi-file?
No, sir. No, sir.
Oh, okay. Okay. In real life production, let me see this further. In real life production, sometimes
this one was
programmers, not all programmers can be working on the same project. Okay? On the same project, everyone is working on it. Okay, and one programmer is working on the front end, another one on the back end. At the end of the day, you integrate everything together. So in real life implementation, sometimes if you have your source code, okay, let me just write something like hello world. Let me write hello world. So let's say I just have a function called print hello world.
If I run a C from
hello, let's say print hello. Okay, and
you want a GUI, you have GUI.
And let's say this is the prototype. Okay, this is the prototype. Yeah, I will write the function.
To see faster.
Let's say
for the Lisp, we have small talk document.
print
then basic,
okay.
C and Lisp bring us the full language. Okay, and Other C we get Objective C.
I love C programming. Just say this is what you want to do.
Windows Phone.
Okay. This is your function header.
Hmm?
This is the function header line, the full implementation. And this is
Java,
where you call it.
Ruby,
So let's say you are
C,
French.
also has an element of program.
Okay.
Right? Also
And
small
you're
dot.
calling the function here. If you run it,
all right,
you can see it work. This is the header. This is the.
All right.
In real life, as
So-
you continue to write program,
Also under C,
you cannot
get the
put
rows
all
and
your
columns.
source code.
Huh?
You can't put
Rows
all your
and
source
Ruby
code in
can
one
be
file,
rows.
in just
And
one
Python, you have
main.c.
to
You
go
can't do that. You can't.
Right.
It will be overwhelming.
Right. So,
Okay,
under
so what
Java,
we'll
you get
do
Scala
is
and then you have the C#.
we create a
The JavaScript
file.
scripts, that one is not.
We'll separate them
C# you get
into
TypeScript.
different files.
Objective C, you have
Okay.
Swift.
So I
C
can
and C#
come here.
Swift.
I
See, look at the
can come here and let's say file. I can come and say new file. Let's say new file,
almost everything.
and let's call it an header file. The header file,
Every application will necessarily
and let's say where's the path. We'll specify the path.
It's also because we
Okay, let's just say this is the path. Okay, let's give it a name. Say hello, and you know it's the header because it's an header file. It has dot h. Click save. Okay, and then it can help you include what we call a guide word to help you prevent duplication. If there's any other header of that type, it will prevent it for you duplicating. So this is your header file. I can actually move my header here. I call this my header and put it here.
Just put inside quote.
Okay,
Inside quote.
I save it. I save it. This other file, I can come and also include
Header files you find inside the program.
another file, and this will be a CPP file on C.C file. Then I claim the .c file. So let me call it the source code. Just say source, and you can see it ends with .c, capital or small letter, it doesn't matter. So finish. Then what happens is I can move this implementation and move it here. Okay, I can move the implementation here. And in this main function, you can see my main function is very clean. It does not have so many files. But however, what I have to do is I have to include these other files. I have to include it. So let's say hash include. You can see now. If you create a file yourself, you create your header yourself. When you create your header yourself, what you will use is you will use double. You will just use double quotes. Okay, and you look for the header. Hello.
So what they do was they put everything in one place.
Dot H because it's an. You close it. Okay. So hello.h. You can also include it hash include hello. See hello.h. So let's see if it will work this time around. So from the main function, whenever you have several functions or several files, where does the program the operating system or the compiler start running from? It runs from the main function. We have several functions. Just imagine we have several functions. Okay. Then where it starts from is the main function. That's why they call it main. the box of all functions. You understand? So I've been able to include this file here and also included it here. So let's run saying something like that on reference to print hello undefined reference. No, it's saying it's not seeing it. It doesn't
Let me just
understand.
do one by one for you. You don't understand it. So let's go ahead and find it.
We are
Anyway,
many
it
other
doesn't matter. We can look at it.
hello. Why is it not seeing it? You-
Let's use our normal which is Fatma.
Undefined reference to
Just do it.
otherwise.
You can use not defined. What for the same, right? This is the modern one. So let's go back to that same file. Here and check. So now it's gone, right?
Okay, let me just do this.
Ah,
Let me just do this.
fine. So let's see which one is
Let
gone.
me
Here.
just do this.
I have an item.
Just imagine I have this.
So let's see. Then we're showing new platforms. So basically this is
So just imagine I have this
I
here.
don't know why the item for this.
Yeah. So,
So let's
oh, sorry.
example, let's just do.
So let's call. Shoot. It must have been
Application blocks. Okay, so it's none of them.
So basically, I wonder.
Let's compare by that.
I should do.
Right, we move.
Why? This is what I'll do.
Look at the files and the
Let me just write it out. Hello. Fish. This is the file. So let me view this. Let's see.
So why is it being cut?
Oh, maybe right. Having the issue.
No place here.
Okay.
Okay, let's just do it.
Okay, you can see I love C programming. So this far, I love C programming. Okay, I love C programming so much. Let me just write so much so that you see that. Yes. Let me test again. While why not loading? Load. So basically, I've included this file saying, okay, it's just like importing everything here, taking everything here and putting it here. You understand? So in this main function, where I saying hello, say, oh, where is the implementation for hello? Is already in another file. So just like when we say print function, when we use print function, you understand all those print functions. Okay, where can you find it? The implementation is in all these standard library or SDA IO. It's there. So what you're doing is you are copying all the files, in those header, and you're dumping it here. So you see that the print hello works. Well, I wonder why it should immediately automatically, as you put your codes, it will give you the other file.
Sorry.
Okay, so that's just it. That's the concept of multi-file. You can actually create multiple files. You understand? Create multiple files and include an improvement. Okay, so that's the concept. That's the concept of multi-file. So we will stop here. We will stop here today. And I want you to practice a lot. It's not just about me teaching you, like, and at the end of the day, people are not practicing. It is important for you to practice and uh, and debug in case you have an error. Okay, so I've been able to talk about pointers. And also, there's something I wish I showed you, which some of you might have read, but it's okay. That pointers, when you're creating a pointer, let's say I have a variable called age, and it's 50. Okay. I can create a pointer to age. You know how we create it and say maybe age underscore PTR. That's just a pointer name. And it's mapped is pointing to age. Let's imagine it's pointing to age. Okay. I can also create a pointer to a pointer. So what that means is I'm pointing to you, you are pointing to, do you understand? I have age, I have age pointer, age pointer, okay? And age pointer is pointing to the address of age, is pointing at age, or let me use the word is referencing age. Okay, so the address of age will now be stored in the pointer. I could, so let me say my address. Let's assume my address is this. Go ahead. And I told you how to get the address of any variable. What do you use to get the address of any variable? Okay. Anyone? Can someone tell me?
It's okay. It's what are the requirements for?
What do you say? I can't hear you. I don't know why the volume is not loud. Okay, so this is a pointer actually. Then I could actually create a pointer to a pointer. So let's say A2. Let's just give it a funny name. A2 pointer. Or like or pointer square. It doesn't matter. And this pointer is pointing to this. So that's why this is a pointer pointing to a pointer. And so this age pointer, let's say is saved, it is in address FF. Okay, so it means here is FF. The reason why I'm going this far to explain is so that when you start working on something like data structure, you'll be able to understand. So I can come here and create a pointer, the pointer. So how do I create a pointer to a pointer? By using double asterisk. Say, let's just say A2 pointer. And the A2 pointer is pointing to the address of what? Age underscore PTR. Okay, age underscore PTR. Someone is saying, can you tell us some things we can do with memory allocation? What are the things you can do with memory allocation? Just like the same way you allocate space for your normal variable to work. You can also just imagine, let me give you a scenario. If you go to the bank today, and say, please, what do we call them? Banker, I need to open an account. I need to open an account. Now, the question is, when they wrote the program, were you factored in when was the account factored in when the programmer wrote the program? Okay, you're not factored in, although they know that yes, this program will scale up, but they did not say, oh, we'll create a memory or an account for so. So you come in, it means they have to dynamically allocate an account, is a profile for you. And those are concepts of dynamic allocation, ways you can actually use. Okay. And let me tell you one thing about with memory, dynamic memory allocation is this. It helps you to efficiently use your resources because it is on need basis. It's just like this ad they will tell you, they will say pay as you go. This one is more like pay as you come. As you come, we create an account for you. We create a new memory for you. It's not that we will now be saying, we assume 500 people will come and only 2 people. So you are wasting your resources. Okay, so those are the concepts of of why you need your dynamic memory. Okay, why you need your dynamic memory. It's on the spot. Everything you've been doing, you can actually dynamically allocate memory for it. So and that's it. So from here, I can come and print and say, okay, I want to print out my results. Then come in, value of age using age variable. Value of age using age variable, is this. So here I will just use age. Okay. So I can come to new line. Okay. I can also come and print value of age using age underscore PTR. Say using age underscore PTR, the value of age. Then I will dereference where I'm pointing at PTR. Okay. Then I can come here and say something like value of age using pointer to pointer. So I can actually say pointer to pointer, P2P. P2P equals that. Then I can come here and say something like this. A true underscore PTR. So with that, it's more like pointer to pointer. This will dereference and say where I'm pointing to. With this first statement, it's going to say, oh, where I'm pointing at, which is the pointer. Okay, it will now dereference again and say, so with pointer to a pointer, you can point to any variable. Okay, so let's see if it works. Okay, you can see using age variable. What do we have? Using age variable, age, we access using age. The second level using age pointer. Since I'm pointing at age, I can fetch what is in age. Okay, and also using pointer to pointer. You can see using pointer to a pointer, I'm able to access that variable. Okay, so that's what I want you to actually know when it comes to pointer, because in data structure you would if you're using C or C++, you would actually need it. Okay, so in C++, where I was using malloc, then you will use new operator. Okay, and how do you free? I think you use delete. Yeah, the delete keyword to help you free the memory. Okay, so we will stop here today, and hopefully I will look at the schedule and see how many more time we have before exam so that I can fix my text. And nothing much. I want you to revisit. Why I'm not stressing you guys is I want you to revisit all you've done. I want you to master it. Master, not just know. You have to master it up to this level, because one thing about programming is the previous knowledge or things you've been taught, you will apply them. You will see it cascading. showing up. So don't just say, oh, they taught us this and that's all. You must master previous concepts so that you'll be able to apply it in this new concept. All right. If I want to ask if there's any question. Okay. If there's any question, fine. If there are no questions, we can actually call it a day. Any question? No one? All right. Since there's no question, then I would call it a day.
So I'm still asking. So this is a function. I still
Call
have to make
a day.
function for it to work.